Good morning, everyone, and welcome to the Homer Energy monthly educational webinar for December 2018, Introduction to Blockchain and Microgrids. I'm Marilyn Walker, the Chief Operating Officer here at Homer Energy, and I'm excited to be with you here today and to have so many of you with us here. We've broken attendance, we've broken registration records today. I guess there's a lot of interest in blockchain, and so our goal with these webinars is to keep you up to date on what's happening in the world of Homer and how to best use the Homer software and related services. And we're going out a little outside the box today and talking about how blockchain technology can work to facilitate and improve the adoption and economics of microgrids. And I'm really happy to have guest speaker Tony Giroti, founder and chairman of the Energy Blockchain Consortium. And I don't think there's anybody on the planet more enthusiastic about this topic than Tony, so I'm going to turn the floor over to him in just a moment.
Excellent. Thank you, Marilyn. I am going to get control of as a presenter, and then I'm going to show my screen, and hopefully you all can see my screen. Marilyn, can you confirm that?
We're all good. It looks good. Yep.
Excellent. Thank you so much, Marilyn, for inviting me to the Homer Energy webinar. Hello, everyone. Thank you for joining from different time zones. I appreciate the opportunity to speak with you. So my name is Tony Giroti. I am from the Energy Blockchain Consortium, and my goal today is to talk about blockchain, and specifically blockchain for the microgrids. So let's get started. Now, quickly, I'm going to do a few things. First, I'll give you just a quick overview of Energy Blockchain Consortium, because many of you may not know that the consortium exists. Then I'll go straight into introducing blockchain. And the way I'm going to describe blockchain, I will assume that I don't want to talk too much about technology, but I want to start from what blockchain is, why it's a big deal, and then I'll peel the layers slowly and tell you a little bit about the technology, but I'm going to go one step at a time. My goal is to really give you an understanding of blockchain. As opposed to talk about feature functionality, I want to really have you understand what blockchain is, and that's my goal. The third thing I'll do is I'll talk about blockchain for microgrids. And I think the best approach is to talk about some specific use cases, and then we'll go straight into Q&A. And when you actually do ask the questions, then those questions will be sent to Marilyn, and she's going to ask me questions, and I will respond. So before we begin, let me quickly make an introduction about myself. I'm actually been in the energy industry for over about 13, 14 years. Prior to that, I've had experience in other industries, telecom, banking, etc. But over the last 12, 13, 14 years, I've been lucky to participate in many different boards and DOE organizations. I also used to be on the council member for the DOE Gridwise Architecture Council. I was also on the board of Oasis Open. I was also the early founding members of the Smart Grid interoperability panels. So before I got into the energy industry, I also started working on many other industries in developing platforms and technology. So to me, blockchain is yet another technology. And I've worked on a few predecessor technologies to blockchain, such as distributed computing platforms. So I really understand blockchain enough that I can give you the insight into it. And before I actually started with a few folks, the Energy Blockchain Consortium, I got involved with DOE on many things, including developing the smart grid maturity model and evangelized DOE's GWAC stack quite a bit. So I've been around the block, building technology, building supercomputers, building massively scalable processors. and working and building companies in the energy industry. So I'm so happy to be here and talking about blockchain with you. All right, so quickly speaking, Energy Blockchain Consortium is a nonprofit with a 501c6 status we applied for. We are based in the Florida area with offices in about 3 or 4 countries, Brazil, Singapore, Europe, and India. We are a completely vendor agnostic, technology agnostic organizations. We have partnership with a number of companies, specifically with the Department of Energy's various different labs. We are working on a number of projects with a few labs. And we are also starting to work with regulators in different states because the application of blockchain isn't possible unless you get the regulators involved. So we are starting to work with that as well. The mission of the consortium is to really identify the most compelling use cases in the energy industry and to see if we can apply blockchain purposefully, meaningfully, for implementing these use cases. And our vision is that we want to see blockchain as an enabler of this energy transformation. It is not the panacea, but it is an enabler to this entire transformation that we are going through. So our approach is straightforward. We are here to do 4 things. We are educating the market. We are developing use cases. We are also developing interoperability standards. And we are getting involved in field trials and pilot projects so that we can learn from the field and bring it back to improving the use cases and improving the standardization, basically. Okay, so having said that, I would also encourage you to participate in our monthly webinars. They are held first Friday of every month. The next one will be in January because of the holidays and stuff. And then thereafter every month on the first Friday. And then we also do a number of conferences and symposiums. I'd like to invite you to a February 4 and 5th conference with Distribute Tech in New Orleans. Second thing, the use cases. We are developing a number of use cases. We call them use case catalogs. And we are developing a use case catalog for microgrids. And I'll give you a glimpse of that today. The third thing is the standards. We have about 7 or 8 working groups. We are developing standards, interoperability standards for data, business, processes, information model, best practices. So these are the standards that we are developing. And of course, the pilots that really sort of gets us close to the real thing. All right, so blockchain for microgrids. Here is what I believe I want to talk about today. Blockchain actually can deliver benefits of microgrid in a very cheaper, secure, and safe way. And I'm going to walk you through some of those use cases. I also have enough information and discussions which are going on that what we believe was difficult to achieve, whether it was economics or the technology, we can use blockchain to achieve some of those requirements or expectations with respect to microgrid. We'll talk about that as well. Number 3, I believe that the blockchain can be used to create new revenue streams for an aggregated microgrid, or even for individuals who are partaking and participants in microgrids. Blockchain can also be used to reduce cost for the microgrid owners, whether it's a small microgrid in a hotel or it's a larger microgrid. There is an opportunity to reduce costs. I'll talk about that. I also believe that the microgrids can have a huge implication and benefit to the utilities, unlike before. And there is a great opportunity to create new type of business models using blockchain. And I'll talk all of this after I give you a quick introduction to the blockchain. All right, so let's get started with the Bitcoin and the blockchain. You've all heard about Bitcoin. I would assume that you've heard it one way or the other, good, bad, or ugly, you've heard about it. And some of you may have also heard about blockchain, but you're not sure about what it is or what it does. You've heard good things and bad things, and you've also heard about hype around blockchain. When somebody asks you, when you ask somebody, what is blockchain, their most instinctive answer will be that it's a distributed ledger. Okay, but then what? Okay, it's got smart contract. Okay, but what is it? So people will give you features and functionality of a blockchain by calling it a distributed ledger. It's with a smart contract, and you can do data mining, and you can do cryptocurrency. Yeah, but what is blockchain? I'm going to actually demystify that. I will talk about why you should care, why utilities should care, why would microgrid owners care, and what about regulatory environment? I think in the microgrid world, there are certain microgrids where there is no regulation, but with the larger microgrids, utility grade microgrids, the whole utility grade infrastructure is used. So therefore, regulatory requirements are very critical there. And many times, many of the utilities come and say, is it going to disintermediate us? Or the microgrid owners can say, hey, is microgrid going to be successful with blockchain, or am I going to not be successful? So those are the questions that people have, and I'm going to walk you through some of that today. Okay, in order for me to really have you understand the blockchain, I want to talk about what is the blockchain. Blockchain is, if you look into blockchain, the tip of the iceberg is actually Bitcoin, but behind it is actually blockchain. Blockchain is the unseen part of the iceberg, actually, that you don't see. And like Bitcoin, there are multiple applications that can be created, such as cryptocurrency. You can actually use blockchain to trade commodities or products. You can also use blockchain to track information or data or assets. Blockchain can also be used for security in terms of managing assets or in terms of making sure that assets can be highly secure. Because what happened, for example, a few days ago, 500 million records were stolen. If we had deployed blockchain, blockchain can provide unparalleled security to provide security of data. So Bitcoin just happens to be the tip of the iceberg application using blockchain, but there are other applications, other cryptocurrencies, other type of trade applications and security applications, which are fair game with respect to blockchain. So let me tell you a story, actually. I think sometimes people really understand things with a story. So if you think about it, about 2007, 2008, something actually happened here in the United States. If you really think about it, we actually had the financial crisis, right? Most of you must have been impacted by it because we had the Great Recession, and there was a huge issue around trust with our financial institutions. Many individuals felt that the banks had missold or misled products with respect to mortgage-backed securities, which led to the entire collapse of some of the bedrock institutions like the Lehman Brothers. Some of us definitely remember that. And while all of that was happening, in August of 2008, actually, Bitcoin was born. Literally around the August 2008 timeframe, Bitcoin was born. Now, why am I telling you this story? Because Bitcoin was born not as an accident. Again, Bitcoin was born not as an accident, but Bitcoin was born to solve the problem of trust. There was so much disappointment in the financial institutions that the creators of blockchain, a team or an individual named Satoshi Nakamoto, decided that we do not want to rely on the trust of these institutions who have betrayed our trust. We want to create some system, aka a machine, that will allow us to encode trust in a machine. Think about it. How is it even possible? how can you have a machine that encodes trust? So Bitcoin was born because of the betrayal of trust. So what is blockchain? I know you've never heard this story before, but I'm telling you this because I want you to understand what blockchain is. It is not just a distributed ledger. That's a feature functionality. Blockchain is actually a machine, a system, a middleware, a technology that allows you to encode trust in the machine itself. Now, what does it actually mean, encode trust? What it means is that in a computing system, we can create a contract, a business logic. We've been doing it for at least 40 years, 50 years. We've been able to write code and we create a way to execute that code. And that code is a contract, right? We have contracts and business logic, and we've been working like this for years now. However, there is no way the results of that contract can be governed, or there is no governance of that contract. It's basically open to human interpretation. The reason we had the financial crisis was because the results of the mortgage-backed security were interpreted by human beings, and they gave mortgages to people that could not afford it. But if we had blockchain, the execution of that contract would not be open to interpretation, and therefore those people would have never gotten the mortgage-backed those securities, subprime securities. So think of blockchain as a technology that allows you to not only encode a contract, which we've been doing for 40 years, 50 years, but it allows you to execute that contract, to be able to execute, which is called the governance of the contract. And that's where the magic lies with the trust machine. It's a machine that allows you to encode the contract and to execute it so it's not open to human interpretation. So how do you actually achieve that? The way you achieve it is that through a process called consensus. The way to achieve trust is through a process called consensus. So what is consensus? Consensus is the ability in a very democratized way to establish trust in the machine through the business logic. And I'm going to make an attempt and see if it makes sense. But if you don't understand, that's perfectly okay. At least it's a primer for you to get to learn about what consensus is. So what is trust and how do we build it? And I'm going to show you that. In order to build trust, one of the basic paradigms is that we cannot really give control to one person or one company or one entity. So by definition, we have to find a way to decentralize control. So one attribute of a blockchain is to be able to decentralize the control. So the decentralization is an attribute of blockchain which results in creation of truth or consensus building. Okay, second, we do not want one company to control the data. So the founders of blockchain decided we must distribute the data to multiple entities. And therefore, we have a distributed ledger. The distributed ledger exists because we wanted more people to have visibility to the data, more nodes, more entities to have visibility to the data in a controlled way, of course, so that one organization does not hijack the data. Or if one company was to be hacked, that would not be the end of 500 million records being stolen. So the distributed ledger is the foundation to achieve trust. Third, the founders of the blockchain said that, well, if the data was deletable or modifiable, then what's the trust? There's no trust. So they said one of the biggest assets is we must not modify the data. So let's make sure that the data is immutable. Immutability is a core attribute of blockchain because without immutability, anybody can change anything, right? And therefore, all the trust goes down the drain. So immutability is an attribute of blockchain to establish trust. Then they said, okay, why do we need cryptography? We need cryptography because even though you may have the data, what if I go and I look at it and now I know what data looks like? I can see your social security number, or I can see your pay, or I can see your health record. That's not a safe environment. It's not trust. So let's try to make sure the data is protected through cryptography. And the last thing is a smart contract. What is a smart contract? The smart contract is a way you can use all of these assets, the decentralized control, the distributed ledger, the immutability, the cryptography, all of this, and encode it to create the business logic and to execute that business logic. So go back to the example I gave you, the subprime mortgage crisis. If we use the blockchain with a smart contract to write the business logic, to give the ARM mortgages to only people who are qualified, let's say that's the business logic, then the machine executes it through smart contract, and the results come up and say, John Smith does not qualify, so therefore he cannot get the mortgage. So therefore the buck stops right there. The execution is a key attribute of smart contract. So a smart contract allows you to actually execute the entire machine in a way that the end result is undisputable. Okay, I hope that made sense basically. I'm going to take now one more angle and peel the layers a little bit, because my goal is to make sure that you really understand a blockchain. So let's take the next layer now of the onion. If you look into blockchain, and I asked you what is blockchain, it'll be hard to describe it unless you know how you compare it to something. In order to describe something, you must know how things work today. So the way the world works today in the world of computing is that you have a company, whether it's a bank or a utility or an insurance company or whoever, they have a business logic, they have an application, and they have one or more databases. All of that data is centralized. Let's say it's an airline reservation system, or it's a your hotel booking. All of that is centralized with a bank or a utility, right? And if the data was to be hacked, everything is compromised, right? But that's how the world works today. It's centralized. If you look into the world of blockchain, the focus is, remember, decentralization. So what does it actually mean? What it means is that when it comes to decentralization, what they do is that they take the data, such as ledger A, ledger B, and ledger C, they spread it in multiple nodes. Why would they want to do that? Because remember, trust. So we must take and spread that across multiple nodes, because we can't trust one company on the left-hand side. So the data is distributed as a ledger. Number two, the smart contract is the business logic. They actually spread that as well across multiple nodes. Why do they do that? Because if I execute a business logic on machine A or node A or company A, and I run the same business logic in company B and company C, think about it, it's going to result in the same output. So company A cannot say, hey, or hijack the whole transaction, or company B cannot hijack, or company C cannot hijack, because they have to match. So there is no monopoly anymore, which is the decentralization aspect of blockchain. So the decentralization of the control, you have the ability to create the trust. So the smart contract is the technology that allows you to look into this data, ledger A or ledger B or ledger C, and make sure that the business logic is run. But in addition to running the business logic, it also provides the governance of the business logic. And that's where the governance part creates trust. So now, if you think about it, we have trust in machine A. Some logic was run and something was managed. Similar thing happened on B, similar thing happened on C. Your natural question should be, okay, we get it. 3 companies are doing the same thing and same results, so there is no dispute. We get it. But how does it all work together? The question is, how does it all work together? And I'm going to show you an example, which I'm now peeling another layer, and I'll walk you through how it all works together. Let's say that a transaction we're talking about is Andy sold 3 widgets to Bob at the rate of $1 per unit, right? So Andy sold widgets to Bob. Now Bob needs to basically pay $3, right? So that's a simple transaction. If you were to take this transaction and execute that on your traditional everyday garden variety computer, you will have Andy sell the 3 widgets to Bob, and Bob is going to pay $3, and you will have a small application. Let's say it's a bank or it's a company, and you will have a business logic, let's call it smart contract, which would say, okay, the amount that Bob owes to Andy is equal to number of units times, let's say $1. That's equal to $3. And the transaction will be recorded, right? This would happen in a typical everyday garden variety computer system that you and I see around us in our work, in our home. However, if this was a blockchain, this is how it will work. That transaction, call it TX, it's digitally stored. No rocket science, everything is as is, status quo, no change. But here is the magic of blockchain starting now. That transaction, TX, is now propagated to another machine. Remember, 3, 4, 5, 6, 10, 15, 20 nodes. So this transaction needs to be propagated to the next node. Why do you do that? Think about it. Because if I did not do this, company B would never know, or node B never knows what A did. So you can't establish trust if everybody is working unilaterally. This transaction propagation from A to B is the beginning of trust. So continue to watch. So now transaction is on the node B. Node B says, I need to verify this transaction. So the verification process starts. So node B says, hey, buddy, company A, are you a legit? And the response is, yeah, I'm legit. This is my number. And based upon some verification of a transaction, company B or node B verifies the transaction. And it says, okay, sounds good. I trust you. Now your transaction that you executed, which is Andy sold 3 widgets to Bob at $1 per unit, I accept that you are right. I'm going to keep it now. So far, so good. Similarly, the same transaction goes to the next node, and the next node says, okay, I'm going to keep it, goes through the same validation process, and it keeps it. So that sounds good. Nothing, miraculous, except the transactions are propagating. So far, so good. And then what happens is that through a few transactions occur. Andy sold 3 widgets to Bob, and Kathy sold 4 widgets to, Don, and this keeps on happening, right? So transactions keep on getting accumulated, TX, TY. So these transactions are happening. Still, I know you don't get it because I haven't really explained the magic of blockchain. Just the propagation of transactions, right? So far, so good. But here is what happens. Blockchains, most innovative aspect of blockchain is, remember, the trust building, the consensus building. So this is what happens. Amongst all the players in the world, we have to identify a leader. Believe it or not, amongst all the players in the world, if this was a public blockchain, the blockchain has to identify a leader, one entity, one person, one computer, who is going to establish trust. Can you believe it? So how do you do that? So the way it's done is the blockchain gives a mathematical puzzle, and I'm not kidding. It gives a mathematical puzzle to all the volunteers who say, I would like to be a leader. I would like to be a leader. I would like to be a leader. They get a mathematical puzzle, very intense mathematical puzzle. That mathematical puzzle is solved by these potential leaders, and one is a winner. That winner creates the block. This leader goes into the blockchain, let's say node number C or company number C, looks into this transaction. Let's say there were 2 transactions. Andy sold 3 widgets to Bob, and Kathy sold 4 widgets to Donald. Those 2 transactions, TX and TY, are basically consolidated, put together into a block. There is a timestamp to it. There's a hash to it, which means it's encrypted. And if there was a previous transaction, it would put a link to it. Let's say the previous transaction was 001 and this is 002. It's going to put a link that says, hey, this is 002, it talks to 001, or it has a link to 001. And that establishment of the block is the establishment of the truth. And a block is created. This creation of the block is basically propagated to node number B and then to node number A. And this chaining of the blocks, which is the establishment of the truth, is the way the blocks are chained. And that's why it's called a blockchain. Okay, I hope that sunk in. I'm going to peel the layer just a little bit more, actually. How do you establish trust? Remember I said that a mathematical puzzle is given to the world of people who are interested in being leaders? Remember I said that? The question you should ask is, that is so strange that a puzzle is given to these potential volunteers who have to solve this mathematical puzzle, who basically become a winner, and that winner now creates a block. That seems so strange. But if you really think about it, how else can you establish trust? Who do you trust to create that trusted block? No one. There's no one on the planet who can be trusted to create that block. So the only way to create the block is to give somebody a problem, and if they solve it and they qualify through the criteria of being a party, and they are the ones who actually establish and create the block. And that process is called the proof of work, actually. So the proof of work is the most democratic way to creating the block, through the process of identifying a solution to a mathematical puzzle and then to creating a block. That mechanism of creating a block is called data mining, actually. And you and I have heard about data miners all over the map. And those data miners' mission in life is to create these blocks, aka establish trust. There are two other ways, actually, to establishing trust, and maybe two or three other sub-ways, but I'm not going to go through the details of it. But these two are very critical. The problem with the proof of work is that anybody can create trust or a block, and the problem is that it takes a lot of energy, physical energy, mathematical problem, and that is a waste of energy. Almost like the whole country of Denmark, the amount of energy spent by the whole country of Denmark is actually used by the data miners today, which is a whole lot of energy wasted. So they came up with a proof of stake concept where it's not the whole planet or a bunch of potential leaders who say, I'm going to establish trust, but it's through identifiable stakeholders. So let's say that we have an environment where we have 16 stakeholders or 12 stakeholders who are core to the system. Then we can nominate a few of them based upon their stake in the transaction or in the machine or in the process or in the business, and say, okay, we will nominate you guys as the ones who will establish trust. So I don't have to go and find a democratic leader in the proof of work to establish trust. So the proof of stake is the most appropriate way to identify and simplify how we can establish the creation of that block, actually. And that is very valuable because it produces much less energy. And it's a way in which we are able to create consensus and the blocks. There's one more mechanism, which is called the proof of authority. In this particular case, the band of folks who can establish the block and the trust is even more narrow. So let's say that in the microgrid world, we have 5 different stakeholders, which is a utility grade microgrid. We could create a private blockchain, and we could have 2 or 3 in that microgrid to be the nominated leaders. So by definition, we can actually establish trust by appointing the leaders that we sort of believe with and agree with. So these are 3 different mechanisms. The proof of work is very expensive, most democratic, but highly energy consuming mechanism. The proof of stake is based upon the stakeholders' interest in the blockchain, and the proof of authority is like people that we trust or companies that we trust, they could be nominated to do that. Okay, so blockchain in energy. I want to talk about blockchain for the microgrids, but I have to set the stage a little bit. So let me figure out just a high level on the utility transformation. And I know that everybody is super duper on top of this, but I have to set the stage a little bit. We're going through a huge amount of utility transformation. We all know that is the digitization of the entire industry. We've been spending millions and millions, maybe billions of dollars in smart grid and smart meters and IoT/OT integration. And the world has been changing over the last 10 years, as we know it. We also know that the whole industry is going through decentralization because there is a distribution of the power plants. Actually, the transformation from the monolithic power plants to the distributed energy resources. We are also becoming more deregulated, and as opposed to the energy going unidirectional, it's going multi-direction. So the whole world is changing as we see it. There's also a lot of democratization happening because as opposed to consumers being passive users, consumers are now actively participating in an important role. They are demanding green energy, basically. They are integrating DERs into the grid. And there's a lot of changes from monopoly to competition. So there's a huge amount of democratization happening. We also know that there is a lot of data being created, and I can almost guarantee you that over the next few years, the volume of data is going to increase multifold, and we will have a data deluge. This is going to impact security and also a lot of the dissonance on the grid edge, which makes the grid edge very vulnerable, which means the microgrids will be extremely vulnerable. So we have to protect our ecosystem. There are also technical challenges in this industry with newer technologies emerging. Transactive energy is emerging as a significant value that would allow us to integrate the bulk transactions from the ISO RTO all the way to the distribution grid into the microgrids. We know that is coming. In fact, blockchain, it would be an awesome tool to facilitate that. We all know that the whole industry is changing and new business models are emerging, and the prosumers are getting a lot of power. So they are becoming the next gen, folks who are going to drive the changes. And then we have changing customer expectations. All of us are carrying our iPhones and demanding just-in-time gratification. And the consumers are completely changing. They're becoming prosumers as we know it, demanding green energy. And the customer expectation is increasing. So the whole transformation of the utility industry is causing a lot of changes in our ecosystem as we know it. Blockchain has a significant value proposition in this ecosystem. I'm going to go into microgrid, but let me give you huge high-level perspective. We can actually use blockchain to harness the smart grid investment, the data that we are creating, the control signals that we are generating. We can use all of that into making our edge of the grid smarter, and we can harness that investment and empower consumers. We can also use blockchain to integrate transactive energy signals into the microgrid actually. And we can integrate the microgrid with the transactive energy signals from the wholesale market and the utility. And we can empower our stakeholders in the microgrid because of the whole decentralization world. We can also create multi-party transactions within a microgrid by enabling participants in a microgrid to buy and sell energy, or maybe a radical thought, but we can actually do a microgrid to microgrid integration. So you could be 200 miles apart, having two microgrids, and through the power of blockchain, you can actually facilitate the energy transactions between microgrids. So there is a lot of opportunity to have multi-grid, inter-microgrid transactional environment using blockchain. Using blockchain, you can also unlock the value of the data by having a higher grade security and by empowering consumers with their own data. You can also use microgrid to solve problems which were economically difficult to solve with the technology challenges that we have with intelligent devices and the IoT and the EV. Now you can actually use blockchain to integrate all of these. And the reason you can do it is because I can, as a technologist, I can tell you there is a lot of built-in capability in the blockchain, such as smart contract, that allows us to build these capabilities rather quickly and deploy them at a very lower cost and with the lower amount of latency. So there are a lot of opportunities to solve problems that were not economical up until a few years ago. Blockchain can also be used to create the utility of the future, where the utility of the future depends upon these microgrids, decentralized microgrids as assets. And we can have a very tight integration of these microgrids, should we choose to, with the utility. We can provide significant value proposition to the utility from a microgrid perspective. And I have a couple of examples on that. And then the customers of today are getting more savvy, and we can use blockchain to deploy utility grade applications for customers. They can actually use to get more engaged with the utility, and they can get more engaged within their microgrid ecosystem, and they can actually even, believe it or not, earn revenue. So there's an opportunity to create business models like that. Okay, so I'm going to go through about 4 or 5 different buckets of use cases, and then I'll pause and we will do some Q&A. So like I said earlier, blockchain can allow you to deliver benefits of the microgrid cheaper, faster, quickly. What you could not do before or could not do economically, it can be done now, basically. And you can use the network effect of these transactions to make it easy. You can create new revenue streams to empower customers to make revenue. We can reduce cost. We can provide more value to utilities and create new business models. So here is a few list of use cases. How do we create value for utilities from a microgrid perspective? Utilities care about their network operation. They care about loss reduction, congestion relief, voltage control, make sure that the security of supply is more efficient and there is more resiliency in the infrastructure. By providing a blockchain-based solution within a microgrid or for a microgrid, there can be an opportunity to provide a resiliency and more security by the microgrid to the main grid. And blockchain can allow you to facilitate that. Earlier, before blockchain, all of that had to be hand-coded. You have to spend time, money, just putting a lot of the code together. But with blockchain, many of the capabilities come out of the box. The transactional environment, the ability to manage these and track these transactions, make sure the data is not lost. All of that capability is out of the box that we can use to provide significant value. Secondly, transactive energy signals can be harnessed from the wholesale market by the microgrid, and the microgrid can use that to participate in demand response. Utilities would love that because now microgrids can be used as an asset when needed, depending upon the microgrid owners. They can actually use it as an asset in demand response and load curtailment. The obvious benefit to the utilities is that they're not investing in the infrastructure, because the cost of investing in the infrastructure is about 6 times higher than the cost of demand response based asset aggregated load. So there's a huge opportunity to provide that value to utilities. You can also improve the reliability of the supply chain within the main grid by delivering the power when actually it's needed. So we can actually actuate the DER or the microgrid based generation so that it can get the most value for its owners or occupants or participants. Microgrids can also coordinate various assets within the microgrid. For a utility grade microgrid, we can use the blockchain to aggregate all these assets and provide a utility grade front to the utility from grid operation perspective, that would be significant because now we have a utility asset in a microgrid that can provide significant value. Whether this utility asset is like a couple of hotels or it's a larger microgrid, we have the opportunity to provide a front or an integration as an asset to the utility. And of course, many aspects of demand response and load curtailment, it can be provisioned with blockchain. I also believe that one of the clear values of blockchain was integration of users and peers. And you can actually use blockchain to create new revenue streams for aggregation of, when you aggregate microgrids, you can do demand response, you can do peer-to-peer transaction. So peer-to-peer transaction is that you have two customers who have solar or storage, and they can participate in buying and selling. And they could be multiple prosumers or consumers in a microgrid, 50, 100, 200, and they can all participate in buying and selling. And the beauty would be if we integrate that with the utility wholesale market, because then they can actually do it in a very smart way. So this is microgrid DER integration at the next gen level, basically. And blockchain can actually facilitate that. Just 3 more slides. We can also use blockchain for microgrid owners and to generate revenue, because when you have the transactive energy signal from the utility to generate power, we can actually actuate the power and create a new revenue model during times of peak demand. So this could be a way to create business models, a more active business model to create a revenue stream actually for the owners. I also believe that if we empower consumers will take the right decision. They can actually participate in buying and selling RECs, for example. They can, once the consumers are empowered, they can decide how and what type of green energy they want to use. So the consumer empowerment leads to demand, and that demand results in new type of applications to emerge. So blockchain can encourage next generation of application and services within a microgrid based upon consumers sort of changing expectations. I also believe that microgrids have a way to completely be disconnected from the main grid, or they could be connected to the grid. And one of the biggest issues that the utilities have with the DERs and the microgrids also is to be able to have security at the edge. They're very protective of their assets on the main grid. And the only way to provide protection, utility grid protection, is by making sure that the point of intersection between a microgrid and the main grid is done right. And blockchain can provide a way to secure the assets, both on the microgrid side and on the utility side, as a convergence of these two different grids. And blockchain can be used to achieve that level of safety and integration, basically. And the consumer empowerment is something that I talk about a lot. Blockchain is not this esoteric technology that only does Bitcoin. Blockchain can be actually used, like I said, for security. It can be used to empower customers. They can decide what they want to use when. They can manage their own energy data. They can actually participate in grid customer interactions with utilities, with smart DER integration. So there are a lot of opportunities that are waiting to happen if we just sort of deploy blockchain to empower these consumers. So last is the interesting model where, as I alluded earlier, a microgrid is a standalone grid that may or may not be connected to the utility. If you use blockchain, you can actually integrate microgrids, which could be miles apart. You can actually use this model of microgrid to microgrid integration to, for example, buy and sell electricity. Or you can actually buy and sell RECs, or you can exchange green energy, or you can be more resilient as a microgrid itself. So you can use the network effect through a microgrid to microgrid integration and get to the completely a whole new level of microgrid operation. So having said that, I'm on the last slide. I am now ready to take some questions.
Great, thanks, Tony. I'm going to dive in because we have a lot of questions, and we'll get to as many as we can. I'm trying to kind of group them so you can answer, integrate them a little bit.
Sure.
So a lot of questions about emerging markets, rural areas, completely off-grid systems. Do you see a case for, I mean, those might not be the same, but maybe talk about purely off-grid systems, and then I'd like to hear about emerging markets as well.
Yeah, so I think one of the classic use cases is for the off-grid systems and the emerging markets. I'll tell you how. So for example, depending upon the size of the microgrid, you can actually have, if the microgrid was utility grade and not big enough, then you can have transactions within the microgrid. You can create an ecosystem of buyers and sellers within the microgrid if it's large enough, such as a small standalone, housing development or a number of housing developments connected with each other. So there's an opportunity to buy and sell green energy, which is going to encourage the use of DER integration. And secondly, there is an opportunity for us to even think about connecting various different microgrids together. So if you're in the rural environment where you have less predictability and more sort of less resiliency, you can connect these microgrids in a way that you can actually leverage green energy across these microgrids. So in the emerging market, there is a significant opportunity to have a higher degree of resiliency and integration between microgrids, basically.
So then we have a lot of technical questions. So one person asked, what about Tangle, which is supposedly technically better than blockchain when it comes to scalability?
There are many technologies which are emerging, which are competitors to blockchain, and I can tell you that blockchain is simply a point-in-time middleware technology. Before blockchain, we had OSF-DCE, Distributed Computing Environment. Then we had CORBA, Common Object Request Broker Architecture. Then we had .NET, J2EE. Then we had SOA, Service-Oriented Architecture. So I can keep on talking to you about this. So blockchain was not something that was thrown in our lap from somebody who has no idea what they're talking about. Blockchain is an evolutionary technology based upon the evolution of middleware technologies. And this is a point in time, a revolutionary technology because of the way the trust is established. The person who asked the question on the performance, I think the performance issue is solved through the proof of authority and proof of stake. So there are certain performance issues around the proof of work that are still in the process of being solved because democracy takes time, and creating a proof of work based trust takes time because of the propagation of data. So until we have a better solution, there are two solutions that have emerged: the POA and POA, proof of authority, and proof of stake. And using these two approaches, we can reduce the latency to near zero and have a very efficient grid. So I believe that blockchain is a truly good technology that can be applied today for mission critical applications.
Great. There's a lot of questions about use cases, not in theory, but of actual operating systems. Are there examples of these systems in both grid connected and emerging markets and US, Europe, and those markets in microgrids?
I think we are in the early stages of deploying blockchain in the microgrid world, both for a utility grid and also for the traditional microgrids. I think the world is a little bit in the early stages. I think people are working on a few experiments, but it's not really like I can give you some empirical data. I can give you anecdotal data of some projects, but I don't have the empirical data, which is that it's been deployed for the last 3 years. So this is still early stage, but many players are starting to dabble and put their toes in the water to see how the technology works, basically.
Okay. Does it require, so one of the questions was from India, where cryptocurrency is not allowed. So could blockchain be used in those areas?
Yes, of course. If you go back to my slide deck, I showed you a page on the iceberg, if you remember that, right? The tip of the iceberg was Bitcoin, if you remember. If you remember, the tip of the iceberg was the Bitcoin. But I told you that that's just the tip of the iceberg. There are many, many different applications that can be created. And here is a page. So in this particular slide, you can have multiple cryptocurrencies. You can have your own coins like Bitcoins, but you can do other things. You can actually do trading, which means that you can trade a commodity. If you can think of any product in the world, pick any product, a widget, you can actually trade that widget. There are two aspects of trade. One is the physical exchange of the good, and the second is the traceability of it. So the blockchain can allow you to track that good in a way that you have not been able to track before with provenance. Provenance is a technical term, a term of art used to say that blockchain can provide the traceability all the way to the genesis of that widget. And you can also have security, unparalleled security. So cryptocurrency just happens to be one type of application, but there are many non-crypto applications that are also viable, such as trading of a commodity, tracking of an asset, and providing the security of assets.
Great. So there's also a lot of questions around, and I know you addressed this a little bit, but maybe we could go back to some of these areas about, well, there's two issues really. One is the amount of energy needed to use blockchain, kind of almost going counter to what we're trying to accomplish with renewable energy, and certainly with probably most of the people who are on this call. Who are part of the Homer ecosystem, where we're really trying to figure out how to use less carbon-based energy. And the other is the latency problem. I mean, you're dealing with electricity where you have things happening in microseconds. And so talk about both of those issues a little bit.
Okay, great question. Both of them are fantastic questions. So let me try to answer the first one. The amount of energy needed for blockchain is gigantic, enormous. And we are talking about the energy industry. We are trying to use less carbon. So what's the catch? What's going on here? The answer is that if you use a truly democratic system on a public blockchain, then you have no other option, at least, let me say 99% versus 1% rule, right? You have very little option but to use proof of work, which requires enormous, gigantic amount of energy, which is contrary to the way the world we live in, that it's not renewable and all that. So one solution to that problem is to use renewable energy, which means that you can have solar panels that power these data miners to reduce the footprint of carbon in the atmosphere. That would be one way to do it, right? But that's a thing that we know is doable, but how many people do it? I think about roughly over a quarter of these data miners are now starting to use renewable energy. But that's not the real answer. The actual real answer is that for the microgrids and the utilities, if you just focus on that, the proof of work is the wrong solution. We do not want to deploy a public blockchain, at least today, in the next 3, 4, 5 years, because you need to start crawling and then walking and then running. You can't be on the running solution day one. So I would suggest you crawl, you walk, and then run. And the crawling and the walking and the running means that deploy a private blockchain. Deploy a blockchain that does not use the energy of Denmark, but to power the data miners, but to use the proof of authority and the proof of stake as the alternatives to creating consensus and the block. So my answer to the question first is that you do not need to do proof of work, which consumes a lot of energy, as your solution. You could instead use a private blockchain with proof of stake and proof of authority that uses a microcosm of that energy. So that's question number one. Question number two, the latency problem. As many of you know, that the data needs to be propagated now based upon the montage I showed you, from one node to the second node to the third node to the fourth node, right? And we also know that the electrons flow at the speed of light. So what's the catch? Like, how can we wait for a latency of 10 minutes where the power is being pushed in speed of light seconds? The answer is that there are two aspects to blockchain. Blockchain is not being used to push the energy from point A to point B. Blockchain is being used to control the data and the assets, which are energy assets. The real physical pushing of the electrons is unchanged, basically. So the blockchain is being used to control the assets, to manage the assets, to manage the data around the assets, and to actuate these assets as a way. But once the asset is actuated, once the asset is integrated, once the asset is registered, the electrons flow unhindered. So there is no impact to the flow of electricity with blockchain, basically. And the latency issue is from a data perspective. The data is the propagation of the data is slow with the public blockchain, and even that is getting faster. But the blockchain that I am suggesting for utilities and microgrids is a private blockchain where the latency issue is no longer there.
So how does a private blockchain then overcome the trust issue?
The private blockchain overcomes the trust issue because, remember I said there are somebody has to create a block, right, which is the creation of a trust. And who would that be? That would be a potential leader. Who is a potential leader? The potential leader is somebody who has a stake in the blockchain. So let's say that we have a microgrid with 2 utilities and 5, 6, 7 different players. So we have like an ecosystem of 20, 30 players. We could nominate in the proof of authority maybe 3 or 4 players who would establish trust because we have trusted them. We wouldn't trust one entity, but we would have 3, 4 entities so they can provide checks and balances. That's one way to do it. The second way to do it would be that the people who have a stake in that trust, in other words, if you control more of the assets, then you have more to gain and lose. So those participants can establish trust. And this would be preordained because we would nominate folks in the proof of authority, and we would also identify folks in the proof of stake who will establish trust or build that block.
Great. Do you know if there are blockchain technologies that are specifically for microgrids that have been developed or people are developing?
I have not come across any blockchain technology specifically for a microgrid. There are some early, 5 or 6 experiments going on where they have deployed some of these technologies, but many of these technologies are not utility grade actually. In other words, they can work in isolation in a microgrid, but in order for the microgrid to really thrive and be successful, you want to make sure that the interconnection to the utility is viable, that the blockchain works with that interconnection, which means that the utility should be able to balance the power between the microgrid and the utility with respect to the voltage and the power factor and the other dissonance and the stuff like that. So I have not seen a utility grade a microgrid blockchain. There are 3 or 4 that I know of which are starting to emerge as early players, but I don't want to name one just to make you biased towards one versus the other.
Okay. So I want to talk about trust again. We have some questions about privacy. I mean, what does this mean for people participating in these things as far as like their data privacy? It can be really, really sensitive stuff.
Yeah, you're absolutely right, actually. So the question is that, like, how do we use blockchain for trust? So if you look into what I'm trying to say, blockchain can be used in establishing the safety of data. How is it possible? The way it's possible is that today, let me just show you this diagram, if you can actually see it. If you look into this diagram, right, the one where I showed you the blockchain here, right? Everybody can see that. If you look into the left-hand side, the way the world works today, the data in the database may be encrypted, may not be encrypted, right? On Friday, we had 500 million records stolen. 500 million records were stolen from a hotel where I actually also stay. And my record was compromised too. And so there's a chance that if you ever traveled, your record was compromised too. Why did that happen? Because one company, that one bank, had this database on the left-hand side where they kept all, Marilyn, your record, my record, and the other 300-400 people on this call. They kept their records. So now, if somebody steals that, it's gone. It's poof. Everybody has it. Now, that data includes potentially your home address, your phone number, and other information, right? So with the traditional model, that data can be stolen. And if data was encrypted, then there is more protection with the data. That's how the world works in a centralized way. Now look into the blockchain. In the blockchain, that data that you see in ledger A, B, and C, by definition is encrypted. By definition. In other words, if you stole the data from ledger B, it is encrypted. So by definition, it's safe, number one. Number two, the data is invalidated the moment somebody hacks it, because they cannot hack ledger A and ledger C at the same time. So there are certain checks and balances built into the system where even if I go to ledger B, and let's say that you owe me $2 and I go and change it that you owe me $2 million, that hacking, that change is going to negate that transaction. So even if I was a hacker and I make a change into the system, it's not going to be perpetual because the data is invalidated. So with blockchain, you have the following minimal amount of security. Number one, you have the data that's encrypted, highly encrypted compared to the box on the left-hand side, which may or may not be encrypted. Secondly, the data is scattered in 3 or 10 or 15 or 20 different locations, so it's difficult to hack all these locations at the same time. And third, if the data was compromised and modified by design, and this happens all the time, that data itself gets invalidated and nobody can then use that data because it's invalidated. So there are some checks and balances built into the blockchain that provide security of the data, and therefore blockchain can be used to secure the data.
Great. So I'm going to wrap it up with a couple more questions because a lot of the people who've asked questions have left. So I really appreciate you sticking around a little afterwards. So one question is, we have a lot of students on the line, and do you know of universities that are offering graduate programs in this technology?
Energy Blockchain Consortium actually is working with a few universities in creating some programs. But right now, honestly, I have not seen programs like that emerge. There are some programs for how does blockchain work, but there's nothing I know at the moment that is something worth talking about. I know MIT has a 6-week course. I also know that a few other universities are offering 2-week courses. We are also developing a training program in the Energy Blockchain Consortium, but that's where the state of the market is right now, basically.
Okay. So a lot of the questions I'm seeing relative to microgrids, and there's a related one, but we'll start with microgrids. Just, how do you see the cost, this additional data layer cost, impacting the market? You know, at what point does the market become more efficient to make this extra cost worthwhile?
That's a loaded question, actually. How does the market become efficient to have this investment? See, at the end of the day, the whole energy market includes a lot of stakeholders who can work together, and also they can work in isolation. I think right now the deployment of blockchain is more in a collaborative way with 2 or 3 players, 4 or 5 players working together. The economics has not played a role yet because people are still in the early stages of figuring out how to use blockchain. So the efficiencies can only come once you deploy certain applications and see how they perform. So we're not there yet, basically.
Okay. And then last question then, if somebody's interested in applying blockchain to their power system, where do they go?
I mean, you can come to Energy Blockchain Consortium and learn about how to apply a blockchain in the energy industry. We have a monthly webinar, first Friday of every month. The next one is actually in January because of vacations and all that. But try to first learn about blockchain. And I can tell you 90% of the stuff on the web is not correct. Not correct. 90% of the stuff on the web is not correct. So be careful, make sure that you are creating the right perspective of blockchain as you learn about blockchain. Go to sites that you trust or that you believe will give you the right information. Don't read a white paper which is out there just because somebody wrote it, because 90% of white papers are just copy and paste. So be a little bit of a savvy buyer is my point. Once you are educated in blockchain, then try to understand the use cases of blockchain. And one of the things that I can show you is that here is an approach to using blockchain. First, create some kind of a high-level plan, like what is it that you want to do. Second, identify some problem in your organization to develop a use case. That's a high level, right? So first create a plan, get educated, and then create some kind of a high-level use case. Third, create some type of a proof of concept, a small baby step to see if this blockchain thing can work for you. And then comes the little bit more, step where you do a field pilot and then you commercialize. So use this approach in baby steps. The education is where you start first, but be very savvy about it. Don't just sort of read everything and believe in it. And my suggestion is to come together into some kind of a consortium or a collaborative effort, like join a group, be part of a system. I would welcome you to be part of the Energy Blockchain Consortium if you're interested, but irrespective of that, just be with folks that you trust. Don't work on it alone. That's my suggestion.
Great, thank you. Well, we could go on for another hour, I think. I do have people writing in about universities that have either introductory courses. MIT apparently has some online programs. These are very much for people who are, in the PhD level of computer science. Högskolan Vestlandet, I'm sorry if I pronounced that wrong, in Norway, they have an introductory course. So, I think this is just somewhere where it's probably changing rapidly, and I suspect that the Energy Blockchain Consortium would be willing to some of that information out there. So, really appreciate your time today. I'm sorry that we didn't get to every question. I'm looking at a big, long list of them. And so, they do a monthly webinar, show up there, and we will have the slides and this recording available no more than a week. So thank you, Tony, and thank you to everyone else. And we'll see you in January. We're going to talk about the complementary nature of solar and wind in remote microgrids. All right. Thank you.
Thank you, everyone. Take care.